Welcome to week 1 of this course on programming with generative AI. We will start by asking these two important questions, and we will try and answer these in today's lecture. So firstly, what do programmers do? And secondly, why is it that generative AI is so good at doing these things that programmers do? So let's start with the first question. So if you ask someone, what do programmers do? A very basic answer is, well, programmers write code. That's a bit like asking, what do swimmers do? And say, well, swimmers wave their arms and legs. Of course, swimmers do wave their arms and legs. And of course, programmers do write code. But just like swimmers wave their arms and legs with a purpose in mind, similarly, programmers write code with a purpose in mind. What programmers are really interested is in solving problems, and problems of a certain category. And programmers solve those problems by writing code which can then run on a computer, and that's how they end up solving problems. Now, programmers cannot solve all problems by writing code. Just as an illustration, here's a problem. I ask, is this a fact that there is a non-dwarf planet beyond Neptune? As you can imagine, this problem is relevant to astronomy. Does it mean that a programmer has no input on solving this problem? No, because a programmer might be able to help with, for example, some elements of the software that get used in designing a very powerful telescope or a complex mission that finally will answer this problem. But it's very easy to see that this problem is not really first and foremost a problem for programmers. It's first and foremost a problem for astronomers. In contrast, let's take a look at this problem. I ask, is this large number prime? Now, this is something that a programmer can definitely help you solve. A programmer can help you translate an algorithm, a series of step-by-step instructions, into code. A good programmer would even be able to tell you an algorithm for this problem. Here is an example of what that might look like. So here's a series of 4 steps. If you follow these steps precisely, you will either end up saying yes or no to this number. Is it a prime or is it not? So let's take a look at these steps. First, let's suppose this given number is n. Then we ask, is this n less than 2? Well, clearly not. This is a very large number. The step on line 2 said, if n is less than 2, then say no. So we will skip past line 2 and we will move to line 3. Line 3 is more complicated. It asks us to consider every integer x from 2 all the way up to n minus 1. This is the number n, so n minus 1 would of course be 184,70722. So for every x from 2 all the way up to that number, we should check if x is a factor of n. This is how we will see if n is a prime number or not. We're searching for a factor of n. If we can find a factor of n, we will of course say no, it's not a prime, and then we will stop. On the other hand, if this search for a factor of n is unsuccessful, if we search all the numbers from 2 all the way up to n minus 1, and none of those x's are prime factors, we will move to step 4, where we will say, yes, this is indeed a prime, and then we will stop. Now, if we run through this algorithm manually, it will be extremely tiring because it turns out this number is actually not a prime. It is the product of 4,111 and 4,493, which means that if we were to trace through this algorithm by hand, we would have to check 4,000 x's before we find a factor. This is what computers are very good at. Computers can quickly run through these steps very, very efficiently without getting tired like we humans do. So this is an example of a task that computers are very good at, and programmers can help us translate this algorithm, this recipe, into something that a computer can then execute very fast. Now, this way of solving this particular problem is not very efficient. It turns out that there is a much faster way of checking if a number is prime, a way that was discovered by some students and their professor at IIT Kanpur a little over 20 years ago. This is a very famous paper, and as you can see, it has been cited more than 2,000 times. Now, in contrast to this problem about prime numbers, which has an algorithm-centric solution, consider this problem. Is this a cat? Now, this is a question you could ask any child, and they would very quickly be able to tell you, yes, that's the drawing of a cat. But if you asked the child, or even an adult, to write down a series of steps, to write down an algorithm-centric solution of telling you whether a given picture is or isn't a cat, they would really struggle. So is this an example of a problem that you would not ask a programmer to solve? Well, as you're probably aware, these kinds of problems are solvable with programs. They require a very different type of solution, not an algorithm-centric solution, but a data-centric solution. You are probably aware that the entire area of deep learning has exploded because papers like this one showed that these kinds of problems can be solved with vast amounts of data and with very complex neural networks. This particular paper has been cited many, many times because such data-centric solutions have proved to be extremely practical in the real world. So, taking a step back, what do programmers do? Well, they solve certain types of problems. And they solve problems that have an algorithmic solution or a data-centric solution. In this course, we will see examples of both types of solutions. Because this is an introductory course, the data-centric solutions that we will see will not require advanced machine learning, but we will provide you with the basis for understanding more complex code, such as you will see with machine learning.